Bryopolis. Bryo is a scientific name for moss, and polis represents metropolis. Bryopolis addresses the issues related to climatic change caused by increased greenhouse gases in the atmosphere. Our research has 4 chapters: urban scenario, biointelligent material, design development, and new urban city. The first chapter analyzes data of the main air pollutants affecting London. The carbon emission emitted portrays East London as having the highest emission, while nitrogen oxides emitted prove Central London with the highest emission and East London with the increased emission rate. Hence, East London is chosen as our study. Existing trees in the 7 boroughs are mapped digitally along with the yearly carbon emission. In the next 50 years, the climate could change to hot summers with loss in biodiversity and urban encroachment, but a few plants such as moss would thrive. We used Euryphium stratium, also called the common feather moss. The properties include mild voltage generation, absorption of NOx and CO2, and support invertebrates. A growing medium, what we term as moss voxel, was devised to observe moss behavior pattern under controlled parameters such as size of voxel, humidity, temperature, etc. The growth pattern of moss samples was photographed and catalogued over weeks. This is sampled digitally to interpret a growth pattern using space colonization algorithm. Here, we explore a design based on our study. In the first prototype, anodes and cathodes were introduced to generate current. Further, an upgrade was done to integrate humidity, temperature, and other sensors to a feedback loop that maintains optimal environment for moss growth. We call this the photosynthetic voxel. This device also houses a transceiver that transmits the data collected by all the sensors. For the second prototype, the design of the voxel allows the moss to grow all around the surface modules. Different resolution of voxels form new morphology. The bigger module has a bio and artificial intelligence. The arrangement of prototypes is generated through solar exposure in hours over season. This voxel wall, Bryo wall, facilitates reduction of CO2 and NO2 levels. We integrated photosynthetic voxel on a building near Stratford Station. Moss inhibits its growth when exposed to direct sunlight, so an internal and external solar radiation analysis was done on the building considering the surface as a substratum for moss growth. A small part of the building is used to illustrate the integration of voxel, wherein layers of vertical stacks combine to form a morphology called bryostructura. Of the 6 stacks, the facade are made of smaller voxel with the free growth of moss to accommodate non-human species, while the interior stacks have larger voxel for restricted growth and control for human environment. Smaller spaces for the shelter and livelihood of invertebrates such as ants, beetles, and moth, while the larger one for human interaction and activities such as gardening, exercise, exhibition, and social gatherings. These novel spaces become a major community area, a respite to the clogged urban neighborhood. The urban morphology of bryostructura expands from a single substrata to multiple along with the landscape in the neighborhood to create a new urban scape. This morphology enables a post-natural coexisting scenario of different kinds of intelligence. Here, the distinction between what is artificial and what is natural is ambiguous. Finally, extending our study to East London, the moss growth algorithm is applied to the 7 boroughs. The moss growth pattern and distribution of voxel are mapped together as fibrous drawing and converted 2D data to a 3D datascape. This datascape and the satellite image is interpreted with machine learning starting from the sources with higher air pollution to become a new urban morphology, Bryopolis, a post-natural city with moss, a non-human biocitizen, and human interaction revolutionizing living spaces and cities.